Okay, the recording has started. Okay. Okay, so I'm just going to show you the lecture for today's class. Okay, so let me share my screen first. And for those who have joined Twitter, I'm going to show you your script maybe in the next class or maybe in the first class of the next week. I have already checked your script. I just have to take the marks from those scripts to the Excel file. Then I'm going to upload Excel file as well as the feedback file. Feedback file will contain the check script file. Okay, we are going to check where you have made the mistake in case you have made any. So let me share today's class lecture with you guys. In the last class lecture, before the class test one, we have seen these things. Okay, we have seen the data transfer type of instruction, load word and store word. Now today we are going to see conditional branch and unconditional jump. Conditional branch means there will be a jump or not. There can be a jump but with a condition. And unconditional jump means there will be no condition set before jump. It will be directly a jump without any condition. Okay, so we are going to understand each of these instructions. First we are going to see these four instructions in here. First instruction is branch on equal BEQ. Here, let me zoom in a bit so that you can see it perfectly. This is the first instruction we are going to see. BEQ, branch on equal. Then branch on not equal, BNE. Then set on less than, SLT. Set on less than immediate, SLT I. I is missing in here, but we have to give a I for any immediate instruction. Okay. So first we are going to learn about these four instructions in the word file. BEQ, BNE, SLT, SLTI. Okay, so for BNE, we have this instruction format in here. We have three operands in here. First one is source register one. Normally, for arithmetic instruction and normal arithmetic instruction, not arithmetic actually. Let me show you. For all the instruction in this arithmetic and logical both. Okay, for both of these instruction we have seen there is a destination at the first. There is a destination register at the first, but here is no destination at the first. There is two source registers at the first. Then there is a address or label given. So BEQ instruction has this format: first source register 1, source register 2, then address or label. If C code is like that, if I equal J, if C code is like that, and I is in source register 1 and J is in source register 2, then we are going to compare if source register 1 is equal to source register 2. If equals, then it jumps to this address or label. If it is not equal, then it just goes to the next line. So it will skip the jump. If it is equal, it will jump. If it is not equal, it will skip the jump. It will go to the immediate next line. For BNE instruction, branch on not equal instruction, there is similar format: source register 1, source register 2. If the C code is like that, I not equal J, then we are going to use BNE instruction. Then we are going to compare if source register 1 is not equal to source register 2 or not. If these two are not equal, then we are going to jump to this address or label. We are going to know what is address and label when we are going to convert C code to MIPS. So we are going to jump if they are not equal. And if they are equal, then we are going to skip the jump. We are going to go to the immediate next line. So is it clear for which type of codes we are going to use which instructions out of these two, BEQ and BNE? Please do let me know. Is it clear to all of you?
Yes,
No
sir.
one is
Got it.
responding. Okay, okay, thank you for the response. Okay, so it is clear to you if the C code is like that. If I equal j, then we are going to use BQ. If I not equal j, then we are going to use BNE. So first thing first, we are going to see a code, C code converted to mix code using these two instructions, maybe one of these two. Then we are going to try to understand these two instructions and see one of the C codes converted using these instructions as well. Okay. So first thing first, we are going to see a C code, and that is this one. If let me delete the solutions from in here. Okay, I have deleted the solutions in here. Now see the question. If I equal j, then f is equal to g plus h, else f is equal to g minus h. This is a C code. You guys clearly understand this C code, right? Please do let me know.
Yes, sir. Yes, sir.
Okay. There is a two question available with the C code as well. First question says, in which register what values are assigned to? Like F is assigned to $S0, G is at $S1, H is at $S2, I is at $S3, and J is in $S4. These are the registers that holds the value of these variables. Okay, now another line is given, but I'm going to come back to that after I give you the solution. Okay, first we are going to find the solution in here. Remember, for I equal j, out of these two instruction, which one we are going to use?
BEQ.
BEQ. Now BEQ, we have written that in here. Now we have written BEQ on here. Can you please tell me, if I is in source 1 and J is in source 2, we can write source register 1 and 2 like this in here. So can you please tell me, what are the two source register we are going to write for I and J?
Dollar S3, dollar S4.
Okay, okay. So if these two registers are equal, then we are going to jump to this address or level. We are going to use level first. Then we are going to replace all the labels with the addresses. Okay. Now we are going to use a label first, and we are going to give the label name in the condition name. Like if these two are equal, we are going to perform the operation of if. So I'm going to give a label name. Remember, label names must be in capital letter. IF. Okay. So if these two are equal, I equal j, we are going to jump to this label if, and I'm going to give a label in here. After giving some line of spaces in here, this is if label, and this is the label name. And I have to define the label in here. To define the label, I have to give the label name and a colon. This is how I have defined a label. So if these two registers are equal, our code will jump from this line to this level or address. Okay. So after coming to this address in here, what it will do? It will do this operation, right? If these two registers are equal, please respond.
Yes, sir.
Okay. So in this operation, what we are going to do is add, sorry, $S0, $S1, $S2. Is it clear? This is F is equal to G plus H. Is it clear? Do you respond?
Yes, sir.
Okay, fine. So after we do this, please let me know if this condition is true and we do the operation of F is equal to G plus H. Do we actually go to else, or do we go to exit after F is equal to G plus H?
Exit, sir.
Exit. So I'm going to give a label name as exit. Remember, the label names must be in capital letter. Okay, so again a label name exit. So what it will do, it will come here, check these two registers are equal or not. If they are equal, it will jump to this line in here and see the next instruction add. It will perform this operation and it will exit. Now what happens if these two registers are not equal? It will skip the jump. It will not jump to this location. So what it will do instead, it will go to the next line in here. So whenever the code is in this line, next line, we have to assume this condition is false. So if the condition is false, what we have to do? We have to do this operation, right? Please respond.
Yes, sir.
So we are going to do the subtraction operation for that. Okay. So is it clear up to now? Please respond.
Yes, sir.
Now, after doing this operation, we are assuming this condition is false. We are actually doing subtraction operation. And after that, do we want to do add again, or we do want to jump to exit?
We will jump to exit, sir.
For jumping to exit, there is an instruction available, and that instruction is normal jump, unconditional jump. Without any condition, jump to this level, go to level, jump to target address, J level. So we are going to give a jump instruction in here, jump to exit. When we are going to define the levels, we are going to give the colons in here. And whenever we are going to use the address or label in the instruction, we are going to use the name only, no colons, only name. So this is the solution for this C code being converted to MIPS code. This is the solution. I will drop this solutions in the chat box in case you might need. So here is the code. So do let me know, is there any confusion in this solution? Any confusion? Can you hear me? Any confusion? Dear, please let me know.
Yes, sir.
No confusion? Okay, fine. So the next code, before we go to the next code, we have to understand two instructions in here. Okay. So do respond when I'm going to describe this instruction, if you get this perfectly or not. So first instruction is SLT, set on less than, this instruction in here. Set SLT, set on less than. If the C code is like that, some register is less than other register, then we are going to use this type of instruction in here. If the C code is like that, if I less than J, then we are going to use SLT, one temporary register, then source register 1, source register 2. In these two instructions, there is no jump. Remember, there is no jump in these two registers. So first, a destination temporary register, then two source registers. So if the source register 1I is less than the source register 2J, then it will, if true, if the condition is true, then it will set temporary variable is equal to 1. Temporary register is equal to 1, not variable. If the condition is false, it will set the temporary register value to 0. For SLTI, what type of code we are going to see? If I less than 5, if this type of C code is given, we have to use SLTI. For SLTI, and again the format is same, temporary register, then source register 1 as I and 5 directly used in here using the I. So it will again, if the condition is true, it will set temporary is equal to 1. If the condition is false, we are going to set temporary is equal to 0. So using the value of this temporary register, we can say if the condition is true or false, right? Please respond.
Yes, sir.
Okay. So now we are going to use this instruction in here. Remember the format, first temporary register, then two source register. We are going to compare the source register to set the value for temporary. If the condition is true, set 1, or condition is false, set 0. So now we are here. I'm going to delete the solution from here. Okay, I have to do one more thing before going to the next solution. That part is missing in here. Your converted MIPS code starts from line number or address 1000. You can see this line, please respond. Your converted MIPS code starts from address 1000. Please let me know.
Yes, sir.
So we have to set address. This is the address number 1000. Okay, normally program counter do have this address. Program counter is a register which has the address of the first instruction, but we are going to normally write the address in here. This is the address number 1000. So each address is of 32 bits or 4 bytes, and memory is byte addressable. So next address should be 4 bytes away. 1004. This is 1008. And remember, I have to take this line in here. So this is 12, and this is 1016. Whenever we have assigned the line numbers, we are going to remove the labels from it. Okay. Now this is if we want to remove this if with the line number or address number. Can you please tell me what should be the address number in here?
1012.
1012. Is there any more if in the code? No if in the code, so we are going to delete the if in here. Okay, fine. So there is a exit in here in the instruction. So what we are going to use in here instead of exit?
1016.
1016. So we are going to delete this exit in here as well. So I'm going to give this code to all of you in the chat box as well. Okay, I'm going to revert this code to original because I will need to explain this code as well. Okay, fine. I have reverted this code to original, so I have given you the address as well. So if any line number is given, we can alter this code with the line numbers, right? We can do that. Now, back to this code, I'm going to delete the solutions from in here.
After placing the numbers, why the last exit been removed?
Exit will be removed because we have replaced the exit with a line address.
So last number, what was that? Oh, yes, sir.
1016.
Yes, sir. Yes, sir.
See in the chat box. I have deleted it from here. Okay. So back to this solution of the code in here. Okay. So there are plenty of lines in here, and I better just. Okay. Now I guess it is perfect. Okay. 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 Now you guys please tell me what should be the solution of this code. If this is I less than j, if this is I less than j, out of these two, which one we are going to use? SLT or SLTI?
SLT, sir.
So SLT, you guys are saying it should be SLT. After we use SLT, you guys let me know what is the format. First, a temporary register, $T0, then two source register. What are the two source register will be used in here?
S3 or S4.
So it is fine. After this instruction get executed, we have to know somehow what is the value of T0 to know whether this condition is true or false, right? Because if this condition is true, we are going to perform this. If this condition is false, we are going to perform this. In order to do that, we have to know what is the condition. Is it true or false? To know that, we have to know the value of this temporary register. If the value is 1, we are going to say it is true. If the value is 0, we are going to say the condition is false, right? Is it clear? Please respond. So we have to know the value of this register, right?
Yes, sir.
So now we are going to compare BEQ using BEQ. Using BEQ, if $T0 has the same value with $0 register. Okay. Now you guys tell me if T0 is equal to 0, 0 register has value of 0, right? 0
Yes,
register
sir.
has value of 0. If this condition is true, if T0 is equal to 0, if t0 is equal to 0, then the original condition of this SLT instruction I less than j is false, right?
Yes, sir.
So if this t0 is equal to 0, we are going to jump to the level false. Is it right?
Yes,
Yes,
sir.
sir.
So I'm going to give some line of space, then I'm going to define the level false in here using the colon sign. Now in the false level, what we are going to do? Subtract operation,
Yes, sir.
this one, right? Again, we are going to check if S3 is less than S4 or not. If S3 is not less than S4, then T0 will be 0. And if T0 and 0 is equal, we are going to jump to the false. Sorry, not false actually, else. It should be else. I am writing false, but condition name should be else, right? As it is if and else, not false. It is else. So we are in the else condition when we are going to do the sub. After that, this exit. Just exit, right? If this condition is false, we do this operation and we go to exit, right? Please respond.
Yes, sir.
Yes, sir.
Okay, now if this condition T0 and 0 is not equal, what will happen? If this 2 is not equal, if this 2 is not equal, it means T0 has value 1 because T0 either has 0 or has 1. So if these two are not equal, if T0 is not equal to 0, then T0 has value 1. So the condition was true, right? So if these two are not equal, it will go to the next line. In the next line, what we are going to do? Perform the add operation, right? Please respond.
Yes, sir.
Yes, sir.
So we are going to perform the add operation in here like this. Then after the add, what we have to do? We have to make sure we do not do the sub again. So what we have to do?
Exit.
So jump
Jump,
to exit.
Oh,
exit,
just sir.
jump, exit. Perfect. Now I am going to give you this code in the chat box, and you guys please let me know if there is any confusion. So now you guys have to do me a favor. If the MIPS code, your MIPS code starts from line number 2000, can you guys convert this code to the line numbers, removing the labels in here? Like we have two labels, else and exit. Can you guys do this? Line numbers start from 2000. I'm
Yes, sir.
going to stop the screen share, only share the Word file, and you guys will let me know in the chat box when you are done. Okay, just convert these labels to the line address. I'm waiting for your response in the chat box. As soon as I have some response, I'm going to go to the next topic. Okay, lot of you have converted. Okay, 2004, 8, 12, 16, so it should be 12. Uh, okay, 16 in there. Okay, 2020 there. Okay, fine, fine. 16, 20. So you guys basically okay. Faria Japan Disha, you haven't converted the else in the 2004 number line. So please make sure you convert that else to 2016. I guess yes. So you guys are doing it perfectly. So I'm going to stop the screen share and share my entire screen. I have shared my entire screen. So I guess you guys know how to convert this. In case you do not know, just let me know. I will help you. Okay. So I'm going to the next code in here. Next code, that is I less equal j. If I less equal j, what will happen? Okay. So can you guys please tell me? We have seen these codes in here. I equal j, I not equal j, I less than j, I less than 5. For I less equal j, have we seen any condition? Have we seen any condition?
No, sir.
So we have to make sure we change this code to one of these codes, like I less. We have to remove the equal from in here. And how can we do this? So be careful, listen carefully. How can we do this? Can you please tell me what will be the condition for this else? If we want to set any condition, when this condition is false, if j is less than I, right?
Yes,
If
sir.
Yes, sir.
if j is less than I, that condition is false. So if j is less than I, if we do this, f is equal to g minus h, else f is equal to g plus h, both of these codes are same.
Yes, sir.
So can we convert whenever there is this type of condition less than or greater than equal, whatever the condition is, we have to remove the equal from that. How? We have to know when this condition is false, because when this condition is false, we are going to do that. So we know if j somehow is less than I, because it is I less equal j for true. If j is less than I, then this condition will be false. We are going to do this. So if j is less than I, we are going to do f is equal to g minus h, else f is equal to g plus h. Now, if I do this, can we convert same type of code like this one, right? Same kind of codes. So can you convert this? Please do let me know.
Yes, sir.
Whenever you are going to convert original code to some other code and then convert it to this type of code, you have to make sure you give this code in the exam paper. Okay. You just cannot find the solution of this like that. You have to say that this code is equivalent to this code, so we are going to solve this code like this, so this is the solution. Okay, so I'm giving you this solution in the chat box. Similar solution, just it was I less than j, f is equal to g plus h. Now it is j less than I, f is equal to g minus h, and in else part it is g plus h. So it is quite similar, just a few changes in there. I have given the whole solution to all of you. So going to the next code, going to the next code. There is the solution, but I'm going to ask you guys to try to find the solution at first. Okay, so here is the code. Um, here is the code. Try this one. Okay, if I less than j and then I not equal k, f is equal to g plus h, else f is equal to g minus h. You guys are going to find the solution on your own. If you can't, I'll help you. There is no problem. I'll give you the solution, but I'm going to share only the slide with you guys so that I can keep my eye on the chat box. Okay, do find the solution of that problem. That is a bit more complicated than the ones we have seen up to now. But I guess you can find the solution easily. Okay, so do find the solution and let me know in the chat box. I'm waiting. And after that, I'm going to show you another code related to the loop. Then it will be the end for today's class. So do find the solution of this code first. I'm waiting for a response in the chat box. Mohib Al Hassan has given a solution. Okay, let me check. Okay, I let them check. Mohib Al Hassan, after the SLT operation, you have to check what is the value of T0. You just cannot jump. Okay, you have to check the value of T0 to know whether this condition is true or false. So that is a incorrect solution to me. And beginning instruction is not correct as well. In the beginning instruction, there is no temporary register. There is two source then the level or address. So do please check your codes before submitting it in here. So let me give you this solution because I guess no one is trying that hard. So I'm going to share my full screen and give you the solutions in here. You guys will help me throughout the solution, what it should be like. Okay, so I have shared my screen. You guys please do let me know if you can see the screen. Okay.
Yes, sir.
You can see the screen, right? Okay, fine, fine. So what we have to do, we have to, should I just give you the solution or just ask you to do this as a homework? I think you better do this as a homework. Here is solution is here, but you better try this as a homework. I can give you the solution no matter what, but that won't help you. I guess you need to practice this at home. I'm not going to upload the word file as well. So I'm going to move to the next topic. You guys have to do this on your own. If you guys do this on your own, the previous course that we have seen will be a lot easier to all of you. Okay, so you have to do this on your own. So I'm going to the next topic. That is the last topic for today's class, and that is loop. So we guys know how loop works in C. Now we have to convert this C codes to mixed code. We have only one line in it. While say 5 equal k I plus plus. Now you guys please do let me know. Do we understand this loop code perfectly? There is some homework as well. I'm going to add some more homework to it. Actually, you guys know this is a homework. Okay, and this is part of the homework as well. Okay, so just let me write this one. So this is part of the homework. It's homework number 1. I'm going to drop this in the chat box. So first we are going to see the solution of the loop problem. Then we are going to see the topic of the homework. Okay. So where is the code? This is the loop code in here. Okay. So while say equal k I plus plus. Okay. Now they are saying I is in $S0. I is in $S0. K at $S1. And the base address of save register is at $S2. Now what we have to do? We have to load this value from memory to a register. Then we have to compare that register with K. If that is equal, we are going to increase I. Until it is not equal, we are going to keep on doing that. Right? Please let me know. We understand the loop perfectly? Please let me know if we understand the loop perfectly. Somebody
Yes,
has
sir.
to. Okay. So what we are going to do, we are going to take this value from say 5 index to a register. To do that, to read this value from the register, we have to use load word. Okay. Load word $T0. $T0 will have the value of say 5, and 5 for 5 it is 5 into 420 and base address of the save register. So what we are doing here, we are actually loading the value of say 5 onto the register T0. This is what operation we are actually doing in here. Is it clear? Please respond.
Yes, sir.
Okay, then what we are, then
20 take sir.
5 into 4, 20, offset. We
Okay,
write
okay,
the
sir. Okay, sir.
offset in here. Okay, okay, okay. So next line we are going to compare on BEQ if dollar T0 is equal to dollar S1. S1 is K, right? Dollar T0 S1. If these two are equal, where we are going to go? We are going to a label named increment because we are going to increment I with 1 each time this condition is true. So if this condition is true, if T0 has the value of say 5 and K has the value of S1 has the value of K. So if T0 and S1 is equal, we are going to jump to this level increment INC, and in that level we are going to add dollar S0 dollar S0 1. Sorry, it should be add I. My mistake. Add I. So is it clear? This is I is equal to I plus 1. Is it clear? Please respond.
Yes, sir.
Okay, then after we do this, what happens? After we increase I is equal to I plus 1, we have to again check the condition, right? After this line, we have to again check the condition. If this is true, we are going to do this again, right?
Yes, sir.
Then we are going to use a loop. Now jump loop, where this loop. We are going to jump again after increasing I is equal to I plus 1. We are going to jump back again in here to check if this condition is true. If true, again I plus plus jump. True, I plus plus jump. True, I plus plus jump. If true, go to INC I plus plus jump. If this condition is false, what we are going to do? We are going to go to the exit, right?
Exit from the loop, sir.
Jump, exit. So to go to exit, we have to give the level name in here, exit. So is it clear? This whole code.
Yes, sir.
If this is clear, let me give it to you in the chat box. Okay. Do let me know if there is any confusion still. Do look at the code and do let me know if there is still any confusion, because I need to know if there is any confusion. Because we have seen two types of codes in here, one for the condition if else and one for the loop, that is while loop. So we have to understand, remember, we have to understand the C code perfectly. If we don't understand the C code perfectly, we are never going to convert it to MIPS code. If you understand this perfectly and understand each of instructions separately, like what load word does, what BQ does, what add I does, then we are going to convert this C codes to MIPS easily. So this is the C code in here, the last one. I wanted to show you this one, the solution, but instead I'm going to give you this as homework. So the much more you practice, the much more you learn. Okay, so this is the homework. While save I equal K, I plus. Okay, this is one of the code, and this is one of the code for homework practice. I have already given this in the task. Okay, so this is part of the homework. Let me give you again. So this is homework. Need to practice at home. So before I go to any more topic, any next topic, you guys have to let me know if there is any confusion question related to this topic. Any question? No question related to today's topics that we have seen. So in the next class, probably we are going to see the checked script in the beginning of the class, and in the later part, we are going to see a new slide. On that slide, maybe we are going to learn to convert function code to MIPS code. Now, up to now, we have seen normal code uh, up to loop. Now, in the next class, we are going to see function codes, C codes being converted to MIPS. So I'm going to stop the screen share here now. Just look at the homework as well. This is homework you already have started trying. So you guys know how to solve this one. So you guys have to find the solution. Before you find the solution of this code, I have to let you know about one thing in here. Can you guys please tell me if this loop is going to end or this is infinite loop?
It is infinite loop, sir.
This is infinite loop. Remember, this is infinite loop. This loop is not infinite loop. Maybe not. Okay, we are assuming I is less than k. So this is maybe not infinite loop. So you have to take measure of that in here. So here save I has some significance in here. So do find the solution carefully. Okay. So this is the thing I wanted to tell you. So I'm going to upload this file later, not just immediately after the class, because you need to find the solution of this one. Okay, so do that on your own and close the work file in here. So I'm going to stop the screen share. Okay. So let me stop the recording as well. I'm going to take the attendance and that will be all for today.